Hi Math 95. These are going to be some videos to go with Chapter 9. You already have the videos that, are listed in Lumen there, but I didn't put my own up yet. So this is going to be the last chapter we do. We're not going to do Chapter 10. That's okay if you're going on to Math 120 next semester. What we do in Chapter 9, this factoring, you will review there, and the other things we would have done in Chapter 10, you'll do in Math 120. So don't worry that you're going to miss something. You'll be fine next semester. But I did want to go over the factoring. So if you look at the notes, there are 7 pages of notes. And the first 2 pages are actually something that I often give my students as homework before we do Chapter 9. Okay, so it's not really a lot of new stuff there in those first couple pages. It's some review that will help us with what we're doing throughout the rest of the chapter. So we're going to do a couple of them together, and then the rest you can kind of try on your own, and you can look at the answers. The answer key for the notes is up, so you can look at your answers there. So for the first one, I ask you to list all the factors of 24 and then all the factors of 18, and then we're going to see what factors they have in common and what their greatest common factor is. So if we think about factors of 24, and we spoke in the beginning of the semester about a way we can really neatly figure out our factors and know we're not missing any. So we go in order. So we have 1 times 24. We have 2 times 12. If we don't know how many times something goes into 24, we can just divide it. So I could do 24 divided by 3, that's going to be 8. 24 divided by 4 is 6. If I try 5, I get a decimal, so that's not a factor. I could do 6, but then I have it here already, so once I'm repeating, I know I've gotten them all. Then the same idea for 18. Start with 1, 2 goes into 18. 3 goes into 18. If I do 18 divided by 4, I get a decimal. Same with 5. And I'm back to 6. So I have all of my factors here. So now I want to look and see which ones are common to those two numbers. What factors do they have in common? Well, they both have 1 as a factor, which actually every number has 1 as a factor. They both have 2 as a factor, they both have 3 as a factor, and they both have 6 as a factor. So for part C, it says list all of the common factors. So we would have 1, 2, 3, and 6. Then part D says what's their greatest common factor? Or you might remember that is abbreviated GCF, and their greatest common factor is 6. So we're just going to leave that for now. We're not going to do anything else with it at this point. But in the next page, we'll be getting into factoring out a greatest common factor, and we'll need to remember how to find them. So you can go ahead and try number 2 on your own. You can pause the video and try that. Same idea with 30 and 16. If we go down to number 3, we're thinking about the same idea, but with variables. So now I have x squared, and I have x to the 5th. Okay, and so if we think about what those really mean, x squared is 2x's being multiplied, and x to the 5th is 5x's being multiplied. So we have a series of questions there saying, can we take an x out of both? Can we take an x squared out of both? Can we take an x to the 3rd out of both? So let's see what that means. So can I take an x out of both of these? Yes, I could say I'm going to take an x out of both of those expressions, and I can do that. How about x squared? Can I take an x squared out of both? And again, if I look at this, I can do that. I can take x squared out here, and I can take an x squared out here, and that works. How about x to the 3rd? Well, I can take an x to the 3rd out here, but I can't take x to the 3rd out here because there aren't 3 x's being multiplied. So the most I can take out is x squared. Okay, I can't take any more out of both of those because this expression doesn't have any more x's. So this then is my greatest common factor when I'm dealing with expressions that have variables, or that are variables. So my greatest common factor, you can see, actually ends up being my smallest exponent, because that's the most number of x's that I can take out of that term. And again, we'll work more with this in a few minutes. So you can see number 4 is the same idea. X to the 4th and x to the 7th, and we want to think about what's our greatest common factor of those. Okay, then on the next page, on page 2, we have a whole series of questions that are asking you to find a pair of numbers that adds to one certain thing and multiplies to another certain thing. And again, these seem like they're all kind of random pieces of information, but we're going to be putting these together as we do our various kinds of factoring. So the first one, there's an example there, but then the first one says, find a pair of numbers that multiplies to 12 and adds to 7. So let me just write this up here so we remember. It's going to multiply to 12 and it's going to add to 7. Okay. So we could just start picking numbers randomly, right? We could just say, okay, how about 5 and 16? Nope, those don't work, right? We could pick numbers randomly, but we don't want to do that. We're too smart to do that. So we want to pick numbers that at least make one of them true, and then figure out which of those also make the other one true. So we're always going to look for numbers that multiply to 12. Okay, that's going to give us a pretty small number of numbers, and then we can look at those and see which of those also add to 7. So what we're doing, if we want to find things that multiply to 12, we want to find all of the factors. Okay, so again, we're thinking about factors like we did on the first page. So if I think of all of the factors of 12, we have 1 and 12, 2 and 6, 3 and 4. So if I'm thinking about positive integers right now, and we'll also think about negative integers in a minute, but if I'm thinking about integers, not decimals or fractions, these are the only pairs that I have that multiply to be 12. So no matter which of these pairs I pick, I've made this true. I want to find out which of these also make this one true. Well, obviously, if you add these two, I'm going to get 13. So even though they multiply to 12, they don't add to 7, they add to 13. These two multiply to 12, but they add up to 8. These two multiply to 12 and add up to 7. So this is my pair of numbers that I want, 3 and 4 on those lines. You can put them in any order. You can say 4 and 3 or 3 and 4. We're just listing out numbers. Let's go down and go to number 8. Okay, so again, 6 and 7 you can try on your own. The answers are up on Lumen. Number 8, find a pair of numbers that now multiplies to negative 15 and adds to 2. Okay, multiplies to negative 15, adds to 2. Well, those first few on that page are all positives, but now we're talking about negatives. So let's just review for a minute how negative numbers work. So if I'm multiplying, a positive times a positive gives me a positive. A negative times a negative also gives me a positive. And one of each, doesn't matter which they are, one of each is going to give me a negative. Okay? So from this, if I have two numbers that multiply to a negative answer, that means that my signs must be different. If they were the same sign, I would get a positive answer. So this tells me that I have different signs, meaning my two numbers I'm trying to find, one of them is going to be positive and one of them is going to be negative. Okay, now let's think about signs when we add. So when I add two things, if I add two positives, I get a positive. If I add two negatives, I get a negative. Okay, think about me handing you some negatives and handing you some more negatives. Now you just have a bigger pile of negatives. if I have one of each sign, the sign of the answer, in a not very mathematical way to say it, is whatever there are more of. Okay? I don't want to say whatever the bigger number is, because technically a positive number is always bigger than negative, right? But if I have something like -2 plus 5, my answer is going to be positive. It's going to be positive 3. But because there are more positives. If I have something like -12 plus 5, my answer is going to be negative. Because there are more negatives. Okay? What's really happening behind the scenes, if you remember, if I'm adding -2 plus 5, think about having 2 negatives and 5 positives. When you have a positive and a negative together, they cancel each other out. It's like moving one step forward and one step back. So those cancel each other out. I have positive left because I used up all my negatives already. There are more positives, so that's what I have left. So my answer would be positive 3. Okay, so we think about all this. So we know from this that my signs are different. I'm adding two numbers with different signs. If they add to a positive, it must mean there are more positives. So this is going to help us when we're looking at our list of possibilities, figuring out which possibility, which pair that adds to multiplies to -15 also adds to 2. Okay, so let's think about factors of -15. I usually start by just thinking about the positive. So forget about the negative for just a minute. We'll put that in. So 15 could be 1 and 15. 2 can't go into it evenly. 3 and 5. 4 can't go into it evenly. I'm back to 5. So these are all of my options. Now I know that I really want -15. So that means that I have to have two different signs here. Well, it could either be 1 and -15, or it could be -1 and +15. So I could try all those options. But we can kind of take a shortcut. We know that since it adds to a positive number, there are more positives in our problem. So if I'm looking at these two numbers, I want the smaller one to be negative because I want there to be more positives. I want the smaller one to be negative because there are more positives in this case, in this particular case. Now if I add these two, I would get -14. Positive 14. If I add these two, I'm going to get +2. So this is my pair that I want, -3 and 5. Now, if this had added to -2, I still would have had the same idea here, except these are adding to positives, right? Think about what I would have to switch so that they would add up to negatives. So there are a couple different examples that you can try there on that page 2, again, and you can check your answers on the answer key on Lumen. So I would actually suggest doing that, stopping and doing those and checking your answer before you keep going with the video, just because all those things are foundational for what's coming next, okay? I'm actually going to stop this video before it gets longer, and then we'll dive into page 3 when we come back.